The lifting capacities section of the chart is actually two parts, one in the form of tables and the other one in text form. The text part helps clarify some of the capacity information that appears in the tables. The tables are arranged in columns and subdivided based on the boom length. They provide the actual capacity values for the crane under different equipment configurations. For example, this part of the table shows capacity information for a main boom length of 70 feet. The columns provide information about the operating radius of the crane in feet, the boom angle in degrees, the boom point elevation in feet, the crane's capacity in pounds with the crawlers retracted, and the crane's capacity with the crawlers extended. Capacities listed in the shaded area are based on the strength of the structural parts of the machine. Capacities followed by the letter B indicate boom positions in which there's too little backward stability, that is, too little resistance to overturning backward. Using this line from the chart, we can see that with an operating radius of 30 feet, a boom angle of just over 68 degrees, and a boom point elevation of 72 feet, the crane has a lifting capacity with the crawlers retracted of 142,800 pounds, or with the crawlers extended of 165,400 pounds. The operating conditions section explains the conditions that affect the crane's lifting capacities. For example, this section of the chart indicates that the crane must be operated in a level position on a firm surface. If the crane is operated in an unlevel position, the boom will be subjected to high side loads that could damage the boom or tip the crane. The machine should be leveled to within 1% of grade. One way to check a crane's level is to place a bubble level on the superstructure near the rotating mechanism or turntable. Another way is to check the crane's level gauge if it's equipped with one. The operating radius section describes the horizontal distance from the center line of the crane's rotation to the center of a vertical hoist line or load block. This measurement is taken with the load freely suspended. We can use this illustration to show operating radius measurements for this crane. One measurement extends from the center of the crane's rotation to the center of the main load line. This is the main load line operating radius. Another measurement extends from the center of the crane's rotation to the center of the whip line or auxiliary hoist line. It's the whip line operating radius. A third measurement extends from the center of the crane's rotation to the center of the jib line. This is the jib line operating radius. The operating radius section of the chart also includes information about the crane's boom angle. The boom angle is the angle between the horizontal plane and the center line of the lower or base boom section. The angle of the crane's boom directly affects the operating radius, and the operating radius directly affects the crane's lifting capacity. The boom point elevation is the vertical distance from ground level to the center line of the main boom point shaft. This illustration shows the boom point elevation for a crawler crane. Any up and down movement of the boom, that is, any change in the boom angle, will directly affect the boom point elevation as well as the crane's lifting capacity. The machine equipment section provides a more detailed accounting of the crane's equipment. For example, here we see that the crane's total counterweight of 122,400 pounds consists of 3 separate counterweights that range from 39,000 pounds to nearly 42,000 pounds. The chart instructions for reeving the main load block must be followed to ensure that the proper number of line parts are used. Each maximum load value listed on the chart should be greater than or equal to the maximum capacity that will be required for the lift. The corresponding number of line parts must be used for the maximum load selected. That number is based on the catalog breaking strength of the rope with a recommended safety factor. The load line and whip line specifications apply to the wire rope that's used for the main hoist and the auxiliary hoist. These specifications must be met before the capacity chart can be used. This part of the capacity chart provides information about the maximum boom and jib lengths that can be lifted unassisted. These 3 blocks provide that information based on different crane positions and boom lengths. Never attempt to raise a boom or a jib that's longer than what's allowed under the conditions specified on the chart. The lifting capacity of a machine changes when different styles of boom tips are used or when a jib is added. A jib deduction block on the chart lists the number of pounds to be deducted from the lifting capacity when the jib is attached. The deduction varies with the length of the jib. Different booms can be used on a crane, and different jib combinations can be used with each boom. The load charts that come with a crane include jib lifting capacities charts. In order for a jib capacity chart to be used, all the requirements listed on it, as well as those on the main boom capacity charts, must be met. Here's an example of a jib lifting capacity chart. As the chart heading indicates, the chart applies to a particular type of jib used under specific conditions. One of those conditions has to do with the jib offset angle. The jib offset angle is the angle from the center line of the main boom's top section to the center line of the jib. The jib offset angle must be known before a jib capacity chart can be used. An important consideration during any rigging job is making sure that the load is properly balanced. Load balancing involves equalizing the weight of the load at various lifting points. Distributing the load's weight in this manner helps prevent the load from bending, breaking, or falling. Load balancing techniques can vary depending on the load and how it's being moved. Extremely heavy and odd-shaped objects often require multiple lifting points or pick points to spread the load and avoid overloading one point. These types of loads often require the use of special rigging equipment such as spreader beams and lifting beams. In some cases, equipment comes with lifting connectors such as lifting lugs or eye bolts already attached to specific locations to help ensure a balanced lift. Load balancing can also be affected by sling location. Slings must be properly positioned to prevent overloading a lift point or damaging the object being lifted. Extreme caution must be used with slings because unknown stresses can develop during a lift if the load shifts or is bounced around. Small changes in the sling angle can greatly affect a sling's capacity. Because of these uncertainties, a safety factor of at least 5 to 1 must be used for all rigging components. During any rigging job, the primary concern is safety. In order to safely accomplish a rigging job, some basic questions must be answered, including who is in charge, what is the job to be done, where will the work be done, and when will the work be done. We can get a better idea of how these questions are answered by watching a heavy rigging job. These 2 workers have to move this load to another location on their company's yard. The first thing they do is meet to discuss who's in charge of what and to look over the load. During the meeting, they discuss where the load will be moved, when it will be moved, and how best to rig the load. They also determine the weight of the load. In this case, the load has a data plate, which indicates a weight of just over 30,000 pounds. Once they've established some basic guidelines, the workers are ready to get started. The rigger on the ground selects the equipment for the job based on the weight of the load and how the load will be rigged. As he selects the equipment, he inspects each piece for wear or damage. At the same time, the crane operator checks the capacity charts to make sure that the crane is of adequate capacity to handle the load. Then the rigger directs the crane operator to position the load hook and slings directly above the center of the load. He then attaches the rigging equipment to the load. With the necessary connections made, the rigger signals the crane operator to test lift the load a few inches. Once the rigger is confident that the load is secure and properly balanced, He signals the crane operator to start moving the load to its destination. Along the way, the rigger and the crane operator are careful to watch for personnel in the area and for obstructions such as overhead power lines. When the load is directly above its appointed destination, it's slowly lowered into place. To complete the job, the rigger disconnects the lifting lines, signals the crane operator to move the lifting hook out of the way, and returns the rigging equipment to its proper storage place.